Now we are going to see transpiration. We know that plants transpire. Removal of excess of water is transpiration. How to prove that? In science always we need proof. So in order to prove the process of transpiration, the plant transpire water, we are conducting bell jar experiment. This is a bell jar. This is the bell jar. Okay. We have to take a potted plant, well watered, rooted potted plant. Then we have to keep this potted plant. Before keeping it, we have to cover the soil with a plastic cup. Okay, I'll tell you why we have to cover it. Then we must keep this plant inside the bell jar. You have to keep the plant inside the bell jar. Okay. Now we have watered the plant. The plant is getting water from the soil and sunlight, because it is kept, the bell jar is glass, sunlight penetrate and the leaves are getting sunlight. Chlorophyll is there. The leaves are green in color, so chlorophyll is there, and photosynthesis takes place at the same time. The excess water, since the plant is absorbing water, the excess water will get evaporated through the leaves. Okay, so after some time, if we keep this setup without disturbing, after some time we can see the water droplet in the inner wall of the bell jar. In the inner wall of the bell jar, we can see the water droplet. From where that water droplet comes? From the leaves. How the leaves are giving water? Through stomata, the water is evaporated. The water vapor comes out through stomata. That process is transpiration. Okay, so with this we are proving transpiration takes place. But why we are covering the soil with plastic paper or cellophane paper? Because if the water droplet seen in the inner wall of the bell jar, it may come from the soil also. The water may evaporate from the soil. In order to avoid that one, in order to prove only from the leaves, the water transpiration takes place only from the leaves, that water only will get deposited on the inner wall of the bell jar. Prove the process of transpiration, we are closing the soil with plastic cover. Okay, so with this we are proving the plant transpiration takes place. Now we are going to prove that transpiration takes place more in the lower surface, because more number of stomata are present in the lower surface. In order to prove the process of transpiration and more number of stomata seen at the lower surface of the leaf, we are doing this experiment. First we have to select a leaf from the plant and keep copal chloride paper. This one is a copal chloride paper on both the side, lower side as well as upper side, and keep some slide and put rubber band. Without disturbing it, we have to leave it. Okay, so the leaves transpire. Transpiration takes place through leaves. We can see the lower surface after 1 hour. If you take and see the lower surface copal chloride paper, the color changes. The presence of water can be seen in the copal chloride paper in the lower surface. After some time, it will be seen in the upper surface. Both the copal chloride paper will be showing the presence of water, but lower surface starts first. Why? Because more number of stomata are seen the lower surface of the leaf. Okay, so with this we are proving two things. One is transpiration takes place through leaves. The next one is the number of stomata are more in the lower surface of the leaf. Okay. Now to show that transpiration takes place as well as the rate of transpiration, we are conducting an experiment with Gannon's photometer, POTO, photometer. This is Gannon photometer, and it has a horizontal tube, graduated tube. One end, the upper end is wide and the lower end is narrow, bent down. It has a hole. Okay. Then it has a reservoir here. Reservoir can be, I will tell you the parts and uses of each part. The reservoir is used for adjusting the water level, the introduction of the air bubble, and rearranging the air bubble in the same distance. So this Gannon spotometer, we are going to, first we have to fill it with water, then insert a twig in the upper end, introduce, by adjusting this reservoir, introduce the air bubble in the horizontal tube. Okay, and mark the level of the air bubble, the distance. Okay, suppose if it is 2 centimeter, and we have to note it down. We have to keep this setup without disturbing it. Keep this setup without disturbing it. After some time, you can see the air bubble moves towards the upper end. Why it moves? Because the water that has been taken by this twig, it is transpirated. Okay, so transpiration takes place. So water from here, it is evaporated. That is through the leaves transpirate the water. So the water from here is going to the upper end. So along with the water also will move. The air bubble also will move. Okay. So if you want to prove it once again, we can, by adjusting the reservoir, you can reset the air bubble here. Okay. Again after 1 hour we can see. So with this we can calculate the rate of transpiration also. But we are with this Gannon spotometer, we are proving transpiration takes place.